Good evening. I am an educator from Kepler Educations, and this is our second video or the second lecture on the GFG POTD series that we had started. So today we will cover the problem of the day of GFG for 21st August 2025. The problem that was provided yesterday was extremely easy, and that's why there is no point in covering that problem. So what does the problem state? The problem is maximize the minimum difference between k elements. So given an array ARR of integers and an integer k, select k elements from the array such that the minimum absolute difference between any two of the selected elements is maximized. Return this maximum possible minimum difference. Now, what does the problem state? The problem is maximize minimum difference between any k elements. So suppose you are given an array is 2, 6, 2, 5, and let's say k is 3, you will be picking up 3 elements from this array, any 3 elements of that array, and you will find the minimum difference between them. For example, if you pick 2, 5, 6, what will be the minimum difference? This difference is 4, this difference is 1, so the minimum difference is 1. If you pick 2, 2, 5, what will be the minimum difference? This is 0, this is 3, and the minimum difference will be 0. If you pick 2, 2, 6, 0, this is 4, and the minimum difference will be 0. So the maximum minimum difference is nothing but 1. So the answer will be 1. Similarly, in the next question, which is 1490231313. 14902313. If you pick up, and let's say k equals 4, so you will be picking up any 4 elements. Let's say you pick up 1, 4, 0, 2. What will be the minimum difference between these two? Any two of these elements. So, for finding out the minimum difference between any two of these 4 elements, it is very evident that you will have to sort it first. 0, 1, 2, 4. So this difference is 1, this difference is 1, this difference is 2. Obviously, you can understand there is no other minimum differences possible, and the necessity of sorting this particular array, because this difference is 3, and which is obviously not a minimum difference. So sorting reduces a large number of extra cases that you need to check. Very good. So the first conclusion is that you will have to sort the array. You will have to sort this particular array. So after sorting this particular array, you will find it will be 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 9, 13. Now, you have to pick up any 4 elements, and find minimum difference between them. So let's say you take up 0, 4, 9, 13. You find out the minimum difference between them as 4, 5, 4. So the minimum difference will be 4. You have to maximize this particular difference. Now, whenever this sort of question comes that you have to maximize the minimum difference or you have to minimize the maximum difference, the first thing that you need to realize is that this must be a question of binary search. How this is a question of binary search? I am coming to that. So let's say the numbers are 0, 4, 0, 1, 2, 3, 4, 9, 13. 0, 1, 2, 3, 4, 9, 13. So you see that the minimum difference that is possible will always be 0. Why? Suppose there is a recurring. Or in this case, since you are sorting this array, the minimum difference that can be possible between any two elements of this array is 1 minus 0 equal to 1. If there was any repetition like 2, 2, 5, 6, then the minimum difference would have been 0. For precaution, people do take minimum difference as 0 in this particular equation like this. But however, we can safely assume that it will be 1 minus 0 is equal to 1. Here also it will be 2 minus 2 equals 0. But obviously you can take the minimum difference as 0 for simplicity. And the maximum difference that can be possible in this particular problem is 13 minus 0. 13, because this is the maximum difference, right? Because anything lies between 0 and 13. So the difference between adjacents of them would be definitely less than 13 minus 0. Very good. So this is the range of answers that is possible to you. The maximum minimum difference between any two elements of the array Whether you take 4 elements, whether you take 5 elements, it will effectively be a difference between any two of the elements of the array. You take 4 elements, it will be effectively be a difference between 2 elements of the array. Any 2 elements of the array. You take 5 elements as k, it will be effectively a difference between any 2 elements of the array. So between any 2 elements of this array, the minimum difference can be this one, maximum difference can be this one, possible. And this, for example, if the value of k is 2, then your answer will be 13. Very simple. However, if k is greater than 2, let's say k is 5, the answer cannot be 13. Why? Because answer is 13 only when you're taking 2 elements. But whenever you're taking k greater than 2, for example, k is you're taking 3, then you have to take at least one element from these 5. Let's say you're taking 4. So 0, 4, 13. You see, the minimum difference decreases. Minimum difference decreases. The difference between 0 and 13 is 13. But the difference between 0 and 4 is 4. The difference between 4 and 13 is 9. So this subarray will provide an answer of 4. So that's why you cannot consider error of n minus 1 minus error of 0. So this is a set of answers. Your answer must belong to 1, 13. This is the conclusion. You have to check. Your answer belongs to this. Now, let us suppose your answer is D. Your answer is D. Let's assume your answer is D. How can you verify if there exist k elements in the array such that it is to be ensured that there exist k elements in the array such that minimum difference between any two of them is D. If this can be ensured, this can be ensured, we can start from 1 and we can move on till 13, and the last number at which this condition becomes true becomes your answer. The last number is starting from 1 and you're moving on. The last number where this condition becomes true becomes your answer. Once the condition becomes false, there does not exist k elements in the array such that minimum difference of them is 4. There does not exist k elements in the array such that minimum difference is D. So you take 4 elements. You take 4 elements, but you cannot make the minimum difference of the 4 elements to be D, because you say suppose you are taking 4 elements such that they're equally spaced. You're taking 4 elements such that they're equally spaced. For example, this one, after D interval there is this one. After D interval you cannot find anything. If D becomes very large, you reduce the number of you start increase. Okay, let's start from 1. Let's assume D is 1 and all numbers are equally spaced. You go by 1, 1, 1. 4 numbers possible. Done. Let k equal to 4. Let's assume k equal to 4. Let d equal to 2. You see, 4 numbers possible. You take d equal to 3. 4 numbers are not possible. Now you understand that when you take d equal to 4, obviously 4 numbers will not be possible. D equal to 5, obviously 4 numbers will not be possible. So once you get a number that is possible, like 2, you break it. You break the loop. That is, you found your number. And you return this number. This is the maximum difference of these two. This is the basic concept of the question that can be solved. Now, so effectively it comes out that it is to be ensured that there exist k elements in the array such that minimum difference between any two of them is D. Very well. So let us assume that the difference is D. You start writing in the array. You take error of 0. You add D to it. You find out whether it exists or not. Let's say it exists at error of 5. You again add D to it. You find out error of 5 plus D or anything greater than error of 5 plus D. You understand this fact? Anything greater than error of 5 plus D will be accepted. Let us say error of 0 is 1. So and D is 3. So 1 plus 3 equal to 4. Let us say 4 does not exist in the array, but 5 exists in the array. You will take 5 because you need minimum difference, and 5 minus 1 is greater than 4. That is greater than the minimum difference. So it is acceptable. So you see 5, and this lies in error of 5. So 5 plus 3, 8. Let us say 8 lies in the array, and it is an error of 3. Error of 5, 8 plus D. It will be 8 plus 3, 11. Let us say 11 exists at error of 11 plus B. So 11 plus 3, 14. So you see, you have got your 4 numbers. 1, 8, 11, 14. You've got your 4 indexes. So this difference D equals 3 exists in the array. Now we'll check for D plus plus. If d plus plus returns true, then you will check, you can call it a recursive function, check d plus plus. So in that you will be checking d plus 2, that number you will be checking, or else if check of d returns false, okay, so this will be a true condition as well. The condition can be rewritten like this: if check of d is true, then check of d plus plus, and if it returns false, return, see, d doesn't exist, so return d minus 1. This is one of the things that you can do. So you understand, you have to move in an iterative fashion in the array. You have to move in an iterative fashion in the array. So let us write a code of the check. Then we will go write the actual final code. So you can write a code as for int I equal to 0. Let us say you have a start. For int I equals 0, I less than n, I plus plus. Let us say you are finding for k with a minimum difference of d. Very well. So you will say if error of I, you will obviously initialize a count. Error of I minus d is greater than equal to, sorry, if error of I minus d, sorry, minus start, what am I writing? Minus start. The first and last. Error of I minus start. If it is greater than equals d, then it is very simple. Start equals error of I and obviously count plus plus. And if it doesn't, then you continue searching, you will not increase count, and finally you will return count must be greater than equal to k. Why? Why greater than equal to? Because if count is greater than equal to k, that means there is positively count number of items whose minimum difference is d. Then since count is greater than k, there must be k number of elements whose minimum difference is d. This will return a true or false condition. Like this. Very well. So this has got, this is, let's say this is the check condition. This is the check. This is the check. Now the main code. The main code. This is the check function. Let's call it the check function. Bool check d, comma k. Now let us write a main condition. You saw you have low as 1, you have high as, this is the mini, this is the maxi. 30. So you will for low to high, you will run a loop. If check off. So minimum difference is low. Minimum difference is, sorry, for low to high. For I belongs to low to high. So the minimum difference at this iteration is I. So check I, comma, here the question has given you the k. If it is possible, then what you will do? You will say answer equals I, and you will do check of I plus 1. If it passes, good. Or you will increase I. Very sorry, you will increase I. Answer equals I. This condition is itself checking. This condition is itself checking. So answer equals I. And if it doesn't, obviously a difference of I doesn't exist with k elements. So the difference of I plus 1 will not exist with k elements. So you will break. And you will return at the end answer. This is the overall algorithm. Now, how is the time complexity of this particular algorithm? You will see that this particular approach is taking time complexity of n check function. So the check function is taking time complexity of n. So this is of n. This is of n. If effectively, time complexity will become of n squared, and space complexity will become of 1. Now, here's the thing. So your low was 1, high was 13, and you're moving low to high. So you see you're moving from 1, 2, 3, 4, 5, 6, 7, 13. You can see that this thing is sorted array, and you have to search something in the sorted array. So this gives the implication of binary search. So this entire thing you can replace with binary search. How? Check function is already there. I will not touch the check function again. I will just replace this particular portion. So you have to check. This portion is replaced by binary search. This entire portion. Which one will work? Which one will work? So, int low equals, it's what? 1. What is low equals? Error of 1 minus error of 0. Sometimes the array can be of one length, so that will be a test case that you will have to add at the top. If you do not want to increase the number of lines in your code, which looks to make it look cleaner, you did do it with 0, because well, how much extra time will it take? Int high equals, you will first sort the array obviously. Int high equals error of n minus 1 minus error of 0. Now you will do the binary search. In this particular array, from this low to high, which is the difference that will suit the best? Which is the difference that will suit the best? So first you take the difference. Keep before taking the difference, we will start in the binary search. Let us keep an answer variable that will be initialized with high, because it's the maximum answer again possible, and you have to find the maximum answer. Now, while low is less than or equal to high, int mid, since the constants, let us take the constants first. Constants haven't been checked. 10 to the 5, 10 to the 6. So for safety precaution, what you will do? You will do low plus I minus low by 2. Safety precautions. You found a mid. You will check if check mid comma k. If it is returning true, we will say answer equals mid, and if it is returning true, if one if 2 is returning true, obviously you can try with 3. So this portion removed. Let's say this is the mid, and there was something before it. This portion, entire portion is removed, and you are taking this outside. So you will make low equals mid plus 1, and you will do else high equals mid minus 1. A while loop ends, and at the end you will do return answer. So you see, this binary search takes the time of O of log n, and the check function takes the time of O of n. Binary search takes the time of O of log n, and check function takes the time of O of n. So effectively your function becomes O of n log n, and space complexity is O of 1. So this is the optimal approach. This you can say was the brute force one, where you are doing a plain iteration, and this is the binary search. You can call it as the optimal approach. And let me go you through the code. You can see that this is the check function which I have named as the is possible function. I will not writing the code in here once again because it is taking a lot of time. So I have done the same thing. I have initialized the counter. This was the CNT variable that was used in this array. If you the question, start was array of 0. I have initialized it with array of 0. I equals 1. I less array size plus plus. If array size minus start equal to mid. So if there is something which is existing greater than a maximum element, then obviously we'll take it into account because this is more than a maximum difference. So this is a number which might appear in our selection of k elements with a minimum difference of d. So you will increase the counter and you will make it as the new element, and you will again start checking. So you will make it as the new element. You start from checking from here. You find that this value has become more than maximum difference. So you start checking from here. You find that this value is more than maximum difference. This value is more than maximum difference. So effectively after the end of the traversal, you have found CNT equals 4 you will have, and 4 is greater than equal to 4. So you will return true. So this is the check portion. Along with that, here you will see you will first sorted it. Then I have set the low as 0, high as this one. Answer is set as high, just like we did in the dry run in the 0 code. So the remaining things are similar, low plus I minus low by 2. If the check is possible, you will store it in the answer, as the mid you will store it in the answer, and you will take the right part of the subspace or the search space. You will take the right part of the search space, and if it is not possible, if it is let's say if it is not possible with the difference of d, then obviously with the difference of d plus 1 it will not again be possible. So if it is d and not possible, you will take the left portion which is lesser than d, and this portion will be discarded. So high equals mid minus 1, and finally you will return the answer. So your overall time complexity becomes O of n log n, or space complexity becomes O of 1. In the previous video, I had forgotten to store this notebook or save this notebook. From this video onwards, this notebook containing these codes will be saved. This code will also be provided in here to avoid any complications. To avoid any sort of complications, this code will be placed here. This is the official code that has been written. You can refer to it in case of any difficulties. Now, before ending the video, I will just provide you some more things. Yes. So this entire notebook will be available, and our future notebooks will also be available in the in our official website. I provided a link. This is our official website where it will be provided to you. In the library section, after you log in, the library section there will be a portion that is coming in that will come in a navbar, which goes by the name of library. There a subheading will appear which goes by the name of resources. Inside the resources, from tomorrow or maybe today, from today midnight, you will be able to find a section which is known as. I'll just put it in here. Which will find a section which is known in the resources part. It is actually a library, and in that part you will find the section known as community, and inside the community you will find this code, this entire notebook. Sorry, you will find this entire notebook, and any further resources that needs to be provided in order to carry on with this POTD series will also be provided in our official website, along with perhaps a recording of this video might also be saved there. So this completes today's video. Tomorrow we will come up with in the next video we will come up with another problem of the day, might be from LeetCode, might be from GFG, the better one obviously, something that will be more helpful in the placement oriented understanding of this particular subject, or if it is necessary we will cover both the GFG and the LeetCode problems. So I think this is all for today. See you in the next video. Thank you.